Bismillahirrahmanirrahim. Is effect of polyvinyl pyridone on self-assembly in biomimetic cationic introduction. What are surfactants? Actually, surfactants are surface active agents. They reduce the surface tension. Surfactant molecule is composed of two parts. One is a head and another one is a tail. The head bear different kind of charges. It may be cationic, anionic, or zwitter ionic or non-ionic. When a molecule with amphiphilic structure dissolved in aqueous medium, hydrophobic group distort the structure of water. As a result of this distortion, some of the surfactant molecules are expelled to the surface of the system with their hydrophobic oriented to minimize the contact with water molecule. At low concentration, surfactant has a property to adsorb over the surface, whereas with the increase in the concentration, surfactant molecules aggregate to form. This is the structure of surfactant molecules. That is the structure of CTAB and cetyl trimethyl ammonium bromide and sodium lauryl ether sulfate. Cationic surfactant. What is cationic surfactant? When we combine cationic surfactant with anionic surfactant, it forms a cationic surfactants. And when we dissolve cationic surfactant in water, it normally forms vesicles. When we add polymer into the surfactant mixtures, what polymer can do? Polymer can be used to tailor surfactant properties, that is aggregation and types of aggregates, to modify surface of vesicle to achieve suitable rheology. Polymer surfactant mixture have number of applications. Polymer surfactant are recently introduced and used in the production of foodstuffs, paints, cosmetics, and petroleum production, additives, aims and objectives. Formation of cationic mixture based on CTAB and SLES in solvent. Analysis of the aggregation existing in cationic mixture in the being of polymers, polyvinyl pyridones K30, K40 and K90 using tensiometry and conductometry. Evaluation of synergy in details of surface excess concentration, area per molecules, free energy of micellization and absorption. In experiment, we did that we combine two surfactant. One is cationic, another one is anionic surfactant. Cationic surfactant is cetyl trimethyl ammonium bromide with SLES, and we mix it in different ratios: 3:1, 1:3, and 1:1. And then we study the effect of polymers of having different chain length: PVP, K40, PVP, K90, and PVP, K30, and by using tensiometry and conductometry. And from this we calculate area per molecule, surface excess. This is a plot of surface tension versus log of concentration for CTAB. Surface tension value are shown to decrease as CTAB concentration is increased. The critical micelle concentration is a point at which amphiphilic molecules start to assemble into large spherical aggregate. Only at low concentration CTAB adsorb to surface. The surface tension lower substantially after that. When the concentration of CTAB is further increased, even further the molecule begin to migrate toward the bulk instead of being adsorbed at the top. When the concentration of the surfactant reach a certain value, surfactant aggregates and form micelle. That concentration is known as critical micelle concentration. This is the plot of second plot is for the second graph is for the surface tension versus log of concentration for sodium lauryl ether. In case of when we mix CTAB with SLES in 1:1, we got this type of large surface tension decreases with increase in concentration. When CTAB and SLESCl mixed in aqueous solution, vesicles are formed. Cationic mixtures show a significant lower critical aggregation concentration when compared to individual components, indicating a strong and attractive interaction between the oppositely charged amphiphilic molecules, which form highly hydrophobic ion pair. Opposite charge head group of CTAB and SLES exhibit high electrostatic attractive interaction. That's why its CAC value is lower. Surface adsorption occur as an ion pair. In pseudo-zwitterine, the value of critical packing parameter approaches unity, and hence vesicle generation begins after the surface is totally saturation. In this case, vesicles are predominantly formed as compared to This is the plot of conductivity versus concentration for acetyl trimethyl ammonium bromide. The concentration of surfactant has a linear relationship with conductivity. We observed that conductivity value increases with the increase in CTAB concentration. We divided this graph into two portions, into two sections: the pre-micelle regions and the post-micelle region. In pre-micelle region, conductivity sharply increases, whereas in the post-micelle region, the conductivity increases steadily. The explanation for decrease in the conductivity in the post-micelle region is due to free ion binding to surfactant aggregate. Micelles are the name of these clumps of materials. Similar trend is shown by. This is a plot of conductivity of CTAB and SELES in 1:1. The critical aggregation concentration rises with the polymer concentration and are unaffected by molecular weight of the polymer. Second, cationic surfactant enter into vesiculated surfactant instead of remaining in the interfacial area and absorbing on the surface of the. This is the behavior of CTAB and SELES. This two graph shows the behavior of CTAB and SELES by using densitometry. When a surfactant or dissolved in water, they cause the water structure to be disrupted, resulting in increase in the system free energy. As a result, they condense toward the surface and are oriented such that their hydrophobic group turn away from solvent, decreasing the free energy of the solution. The density of CTAB rises as the concentration of CTAB increases. The fact that density may provide a higher value of CMC is quite very fascinating. Similar trend is shown by the. When we mix CTAB and SELES in 1:1, cationic vesicle had a monodisperse population of medium-sized aggregate and high storage stability. In comparison to the pure component, cationic mixture had a high surface activity and a low critical aggregation. We calculate various parameters by using for cationic surfactant system. We calculated surface excess concentration and area per molecule, Gibbs energy of adsorption and Gibbs energy of micellization. For CTAB, CMC calculated value 0.8 millimolars and we measure it at 300 degrees centigrade, whereas the degree of ionization is 0.23 and degree of counterbinding value is 0.61. Whereas Gibbs energy, we observe negative Gibbs energy of micellization, that is minus 3.6 into 10 raised to 4, which show that the reaction is thermodynamically feasible. CTAB in distilled water, where we calculated surface excess concentration and area per molecule and free energy of adsorption, which is and the value is also negative, which show that. Similarly, different parameters are calculated for anionic surfactant system SLES. Here the value of CMC is calculated is 1.57 millimoles and the degree of ionization and the value of degree of ionization is 0.3, whereas degree of counter ionic binding is 0.7. And we calculated that Gibbs energy of micellization value is 0.44, which is negative, and we show that this process is thermodynamically favorable. Similarly, these different parameters are also calculated for cationic mixtures and the negative value shows that the reaction process is quite. Conclusion: the surface tension value observed in pure cationic mixture are higher as compared to cationic mixture with polyvinyl pyridone. The fact that change in Gibbs energy of micellization is negative indicates that micellization is thermodynamically desirable. In case of single surfactant, the value of area per molecule is lower as compared to cationic mixture. In pseudo double Zwitterionic ionic surfactant that displays stable vesicle formation, the critical packing parameter is approximately unity. Stable vesicles are formed in case of pure cationic surface, and the concentration of cationic mixture is also called critical vesicle concentration, and we represent it by. Thanks.